Hello and welcome to QED Stata 5 from part S18. This data on ethnicity and medical care access in Cambodia. So we're going to import the data first from this spreadsheet. So you can see we have these 4 variables, all just yes/no variables. So let's just go ahead and import those. Same kind of command as before. And as before, we want to recode those because at the moment they're all just string variables. So they're all going to be written in red, the y's and n's. We need to recode those as 0 for n and 1 for y. Now I decided that it's taken a long time to do some of the previous codings. Well, not a long time, but there's a more automatic way of doing it, as I told you before. So let me just show you that. So rename, for a start, what I'm doing here is that this star stands for all the variables. So this will just add on struts all the existing variables. So that part there changes all the variable names at the moment. So just puts that strut on the end. So now these are the string versions. I'm going to create some new versions and then wipe out those old versions. So the steps are going to go through. So as it says in the instruction, that's the first part. And then this egen is the automatic way of recoding. So egen takes the first variable, the ethnic group, and it puts it into groups according to the ethnic string. So it looks at all the different values that that string version takes. So basically just 2, the n and the y. So for each different value, it just numbers it. The downside is there's no control over how it numbers it. It always just numbers it in alphabetical order. So n will get 1 and y will get 2 because that's alphabetical order. And also, it always starts 1, 2, 3, 4, whereas here we need it to start at 0 because of the test we're doing. So after we've done that, I'm going to subtract 1 from all those values so that the 1 goes down to 2 and the 2 goes down to 1. So it's a quick way of doing it, except that in this case it numbers us with numbers 1 and 2 instead of 0 and 1. So we have to adjust it by subtracting 1. But if we do that, you can hopefully see that it's created it. So it's created the 2 and the 1. Not many 1s. There's 1 there. And the next stage is this replace thing. So we do that. That's changed it to 1s and 0s. So it was 1s and 2s. It's removed 1, so it's now 0s and 1s, which well it has to be. You can see the 0s and 1s match up with that first column there. So that's the 0 there, and the others 1s, and so on. So we need to do the same thing for the others. So it's the joy of using the coding again, is we can just do the whole thing. Just by copying and repeating the thing, almost virtually the same code, just with a different variable name. So that goes through the rest of it and finally labels the values. So another nice thing is that here that this value label, yn label, 0 is no, 1 is yes. That's the same for all those different variables. So you can just label the values of ethnic and DP3 and measles, and all the variables at once, label with this yes/no label. So that does it in one fell swoop, and then get rid of the string version. So all the string versions. So here I've got to remember how far I got to last time, because it doesn't like doing the same thing too many times. Yeah, already it's good to those first 3, so just do the rest of it. Yeah, no, so it's done it. So you can see it's got rid of the string ones, drop those, and we're in this situation now where everything's coded as 0s and 1s, but it's got nice labels. We can see what it means here. Finally, this command here is just a way of getting some frequency tables so we can see how many of each sort we got. I'm going to make frequency tables and then answer this question. Does it look as though fewer than half have had the DP3, this diphtheria, typhoid and polio vaccination? We can test that. So let's first just do the frequency tables. see what this looks like. So that's the frequency for ethnic. So it looks like about 90% of the dominant Khmer ethnic group and 10% all the others put together. When you look at who's had and hasn't had the diphtheria, it looks like around about 50% each haven't had that DPT. The third instalment is important to get a lifelong immunity or long-lasting immunity. So those 3 diseases. Slightly more yeses here than no's, so it looks like measles might be more than 50%, and undernourished, overnourished, it's about this much percent here. So it looks as though, to answer the questions that it asks you about these things, does it give us strong evidence to think that fewer than half the population have had DP3 vaccination? Well, looks quite close. I mean, in the sample, fewer than 50% have had it. That's in the sample. I'm not sure that will generalise the population. It's so close, could be random. How about more than 50% have had measles vaccines? That looks a bit more. That might be enough evidence there to say yes, that holds in the population. There's quite a big difference in the sample. And more than 10% severely underweight, where 13% in the sample. It's quite a large sample, so that's probably enough to say I'd expect that would be significant. So I'd expect this does hold in the population. This does hold in the population, and probably not that one, or we can't be sure it does. But to find out for sure, we can do a test. But I think we'll leave that for the next video because this one's getting quite long. So for now, thank you for watching.